Hello everyone. Today we are going to talk about the most popular integrated circuit in electronics, the 555 timer. I think whether you are a hobbyist or a student, this is the most known component, and so I hope you will enjoy the session and find it very informative. All right, let's see what the 555 timer is. So the 555 timer is an integrated circuit, and it's one of the most widely used chip in electronics because it can function as a timer or an oscillator, or even you can use it as a flip-flop. So we can commonly find this timer in two versions, an E555, LM555. So while these two shares the same pinout and functionality, so they differ slightly in terms of the temperature stability and supply voltage sensitivity, and also they prioritize the threshold and the trigger pins differently. So let's talk about the pin configuration. The 555 timer comes in 8-pin package. So to pin 1 is always located to the left of the notch, or sometimes it's a dot on the chip. If you locate the dot, then you'll find the first one is right on the left of the dot or the notch. So let's go over each pin briefly. So pin 1 is, you call it ground pin. So this connects the negative terminal of the power supply, or just basically it's the ground. Pin 2 is a trigger pin, so it activates the timer when the voltage drops below 1/3 of the supply voltage. We can explain this a little bit later. So the output, the third one is the output pin. So this delivers the output signal. It's either higher or low. So the fourth one is the reset pin. So this resets the timer. It's usually connected to the supply voltage to disable the reset function. The control voltage pin is the fifth one. This always this allows the adjustment of the threshold voltage. Typically, we connect this to a capacitor for the noise immunity as well. And pin 6 is the threshold. So this monitors the capacitor voltage to reset the flip-flop when it reaches to 2/3 of the supply voltage. So the seventh pin is the discharge pin. So this helps to discharge the timing capacitor through an internal transistor. And the last but not least is the power supply input, which we call as VCC. So this typically connect to 5 volt or 15 volt, for the supply voltage. If let's now look inside the 555 timer. Internally, it consists of 2 voltage comparators and a flip-flop and a discharge transistor and a voltage divider made up 3K resistors. So this voltage divider evenly splits the supply voltage into 3 because they're equally distributed. So the point between the first and the second resistor is connected to the comparator 1, and the point between the second and the third resistor is connected to the comparator 2. All right, so now let's see what the comparator is. The comparator is another electronic device. We symbolize it with a triangle, and it has 2 inputs and 1 output. So the input, which called inverting input, is symbolized with minus, and it's V. We call it V minus, the voltage. Another one is the non-inverting input, which symbolizes with plus, and as we symbolize it with V plus. If the V plus input is higher than V minus, then output goes to high. If the V minus is higher than V plus, then this time the output goes to low or 0. So you can think of this as a simple voltage based decision maker. All right, so let's see how the comparators affects the flip-flops. We know now that each resistor has 1/3 of the supply voltage, VCC. So in this case, the comparator 1 the threshold voltage is compares to 1/3 of the supply voltage VCC, because we have two resistors and it each has a 1/3 of the VCC voltage drop, adds up to over 3, 2/3 of the VCC. On the other hand, the comparator 2 compares the trigger voltage to 1/3 of the VCC, only one resistor, and the voltage drop is 1/3 VCC. So the comparator, if the threshold for the comparator 1, if the threshold exceeds to 1/3 of the output of the VCC, so output goes to goes to high, and it's logic 1. This resets this. Actually, this is the reset signal. So if the for the comparator 2, if the trigger is below the 1/3 of the VCC supply voltage, then output goes to high. This is the set signal. So basically, it's the comparator 1 controls the reset, and the comparator 2 controls the set. Okay. So if we think that if you think that the VCC, or the supply voltage, is 6 volt, then this point has a voltage drop of 4 volt, and this point has a voltage drop of 2 volts. Then in this case, if the threshold input is higher than 4 volt, then for the comparator 1, output goes to high, which reset is logic 1. If the threshold input is lower than 4 volt, then for the comparator, output goes to low, and reset is logic 0. For the trigger, if the trigger is higher than 2 volt, then output of the comparator 2 goes to low, which is 0 for the set. If the trigger input is lower than 2 volt, then the output of the comparator 2 goes to high, and set is logic 1. So basically, if the input is lower than 2 volt, the comparator 1 is low and comparator 2 is high, so which means reset is 0 and set is 1. So this sets the flip-flop which comes after. If the input is between 2 volt and 4 volt, so both outputs are low, which means reset and set, they both 0, and we know that if they are both 0, nothing happens to the outputs of the flip-flop. So if the input is 4 volt, higher than 4 volt, then comparator 1 is high, the comparator 2 is low, which reset is 1 and set is 0, then this resets the flip-flop. All right, that's all for today. Thank you for listening. See you with next video. Thank you so much for watching.